Good morning, students. Today we'll start with the next point, that is electric power. Electric power is defined as the rate at which electrical energy is consumed in an electrical circuit. The amount of energy consumed in electrical circuit and at which rate it is, that is the electric power. The rate at which work is done, that is, when we are talking about electrons gain energy from a voltage source like a battery. So, electrons are able to have energy because of a battery, and we are able to measure that energy in volts, which is joules per meter. We measure the energy in volts, which is joules per coulomb. We measure it in joules per coulomb. We are able to measure the energy in volts, that is, which is in joules per coulomb. Electrons pass through the circuit and collide with atoms in components. So when these electrons are able to enter the circuit, what happens? They are colliding with the components in an electrical circuit. Due to this collision, the electrons transfer their energy to those components. That is, electrons will lose the energy. This energy is converted to heat, light, or motion. So when the electrons gain energy from a source, they enter the circuit and they collide with the component, atoms of that component. Due to this, what happens? Due to this collision, what happens? The energy they have, the electrons have, is transferred to that components. They lose the electrons, right, or lose the energy. And this energy is converted in the form of heat, light, or motion. The symbol of power is P, and the SI unit is watt, which is written as capital W. 1 watt is equal to 1 joule of electric potential energy being used per second. What is 1 watt? 1 watt is equal to 1 joule of electric potential energy being used per second. So we can write it as 1 watt is equal to 1 joules per second. How will we calculate power? The power is the rate at which work is done. Power is the rate at which work is done. So we can write P is equal to W upon T. That is work done upon time. So power is the rate at which work is done. So work done upon time. Work is equal to charge into potential difference. We know that work is equal to charge into potential difference. Now substituting the value of W in the above equation, we'll get P is equal to QV upon T. Now we know that I is equal to Q upon T. That is, can be written as Q is equal to I into T. Now substituting the value of Q in the above equation, we get P is equal to I into T, that is substituting the value of Q into V upon small t, cancelling the small t from numerator and denominator. The power P is equal to I into V. Using Ohm's law, V is equal to I into R, that is Ohm's law. Substituting the value of V in the above equation, we get P is equal to I into R, that is P is equal to I square R. Again using Ohm's law, we know that I is equal to V by R, that is P is equal to V by R into V. Hence P is equal to V square R. That is, we have three formulas to calculate power. We have three formulas to calculate power. Which are the three formulas? We have total three formulas. Which are the three formulas? The first one is P is equal to I into V. The second formula is P is equal to I square R. And the third formula is P is equal to V square by R. These are the three formulas with which we can calculate the power.